In this lesson, we are going to look at dilutions. And here's a picture of a dilution. We have frozen orange juice, and it's being diluted with water. So this is the process of reducing the concentration of a solution by adding more solvent, which is usually water. So let's take a look at a situation here. We've got a situation where we're going to dilute something, whatever it is. There's a concentration, moles involved, and a volume. Doesn't matter what they are. Just picture any solution in your mind, and we're going to dilute it. So we're going to have an after solution. So we've got a before here and an after. So picture that in your mind. And my question is, what happens to our three variables as we do this dilution? So let's think about this. So we've got a volume here, whatever it is. Well, what happens to our volume of solution 2 after we dilute something? Well, it's obviously got to increase. Well, let's talk about our concentration. Again, whatever the concentration is, after we've done the dilution, what's happened to our new concentration? Well, we've added a bunch of water, so it must have decreased. Lastly, moles. We had X number of moles. Well, with our moles afterwards, are we adding anything to it? No. So it's actually staying exactly the same. There is no change in the moles, which means it is a constant. Whatever we had in solution 1 is the same as in solution 2. We have a K for a constant. So let's use that to develop a formula. So here is our concentration formula. C equals N over V. And we've got it for the before and the after. So what we want to do is we want to rearrange it for N. So what we're going to do is we're going to cross multiply N here on both sides. So we get N equal C1 and V1. And at the exact same time, we're going to get the same thing on the other side. Now here's a little bit of logic. If N equals C1 times V1, and N also equals C2 times V2, well, these two statements must be equal to each other. And this is our dilution formula. So moles are not considered. You can forget about moles when it comes to doing the dilution formula. So let's go ahead and see how this formula works, because it does work the same every time, which is kind of nice. So what volume of 0.25 molar HCl can be created by diluting 10 mils of 12 molar stock solution? So when you read through a problem, it's important that we collect the numbers that go together. So here's what I'm talking about. These two numbers go together. We have 10 mils of a 12 molar solution. So mils indicates a volume, so let's call this V1. And molarity indicates a concentration. Let's call this C1. Now, reading back on the rest of the question, it's asking what volume of 0.25 molar. So let's call this V2, and let's call this C2. When it comes to using the formula, it really doesn't matter if we call these two things C2 and V2 and flip it around. It's all going to work the same. Anyway, once you have identified your variables, I like to organize them and rewrite things. So our C1 is 12 molar, and our V1 is 10 mils. Now, I have not converted this to liters. It's fine as long as we're going to be consistent in our questions. So our answer in the end is going to come out in terms of milliliters. Now, if you do, here's a side question here. If you have a question with a volume that one's in liters and one's in milliliters, you must convert so that you're being consistent. Either work both in mils or both in liters. In the previous section, it was important that this volume be converted to liters because concentration is in moles per liters. Moles per liter. Now here we can cheat a little bit, and just again, like I said, as long as we're consistent, you should be good to go. So we're going to figure out this question. It was in mils. Our answer is going to come out in milliliters. So there's our C2 and our V2. We're going to solve the V2. Now there's sort of two ways you can do this. I don't care which method you use. So there's our formula. First method of solving is I just like to plug in all the numbers. And then from here, I say to myself, okay, I want to get V2 all by itself. So I'm going to divide both sides by, well, whatever's with V2, which happens to be 0.25. So the 0.25s cancel out in theory. And you sort of get, I'm sorry, the 0.25s cancel on this side, and there should be another 0.25 over here. So your V2 essentially is 12 times 10 divided by 0.25. Now, some people like to rearrange the formula right off the bat. So there's the V2 formula rearranged. It's really the same thing as what we just did. There's all the numbers that are plugged in. I kind of glossed over it a little bit in this step here, but it's the same numbers, and we get our same answer, of course. And notice that both of our answers are in milliliters. I guess you could have also said 0.84 liters had you converted this original 10 into liters, which isn't necessary for dilutions. So there it is. Enjoy doing dilution questions because they're all exactly the same.